Greetings all, Joseph Kursky here, geographer and educator, with you to explore the world's latitude and longitude and locations with the 3D Scene Viewer, which is part of the ArcGIS.com platform from ESRI, Environmental Systems Research Institute. I'm looking at a 3D globe. I'm not even signed into anything. All I need is a standard web browser with a tablet or a laptop. You can even do some of this on a phone, although you do need, since it's mapping based, a little bit more real estate. I'm looking at latitude 0, longitude 0 off the coast of West Africa, and I can see here that the prime meridian runs up through West Africa, on into Spain, and on over into England. We also have the 5-degree graticule on here, the 5-degree grid of latitude and longitude. So again, the mainstay of most earth science, environmental science, geography courses is teaching about latitude and longitude, and this is a great teaching tool right here. It's also a good research tool, as I'll get into later in this video. So you can see the 5-degree grid on here, and you can see how the longitude lines converge at the poles. And for clarity, they are actually masked at the poles. You don't see all that detail because the map would just actually be too cluttered. So you can see that it goes to about 65 or 70 degrees north and south latitude. Fascinating to be able to do this. Another thing that we often do in these courses is, for example, along the equator, have the students measure with the measure tool and see what 5 degrees of longitude is at the equator and compare that against what 5 degrees of longitude is distance-wise at, let's say, 45 degrees north latitude or 50 degrees north latitude. And they'll see that the longitude lines converge away from the equator as it is meant to. So one of the advantages of actually signing into ArcGIS.com is that you can add layers. And here I'm going to add the 1-degree graticule, because I know you viewers of this video love geography and geographic information systems, and so you want more detail, as I do. I'm going to select the NOAA graticule, 1 degree of longitude, 1 degree of latitude, from the National Oceanic and Atmospheric Administration. And now if I zoom to Africa here, or anywhere around the world, I can see the 1-degree graticule. Now these layers are smart, so when you zoom out, you see less detail. When you zoom in, you see more detail. Again, that's one of the wonders, the glories of web-based geographic information systems as served with web mapping applications such as this one right here. You can build your own, you can save it, you can just open up ArcGIS.com and go to the 3D Scene Viewer and start exploring as I'm doing here. Again, wonderful teaching and research tool. Look at this, 69 miles, 111-ish kilometers across 1 degree of longitude at the equator. And then again, comparing that to what is the length of 1 degree of longitude in my own latitude, for example, Minnesota or Canada or Peru or wherever I happen to be located. So these measure tools are here on the right side in the 3D Scene Viewer. Now I'm going to measure across a arc in Texas, and I can compare that against what I had on the equator. Again, fascinating to be able to do this at your fingertips. Now, I am looking at the topographic base map, but you can change the base map to whatever you want. Imagery of various kinds. You can also add layers, just as I did with the graticule. You can add the ecoregions. You could add population density. You could add a lot of things to these 3D scenes and also 2D maps in ArcGIS Online. But we're just focusing on the latitude and longitude right here. So you can see that one of the layers that I've got in here is the Tropic of Cancer, Tropic of Capricorn, and I'm doing some more measurement here, and I'm comparing the distances as they converge toward the poles here. 1 degree of latitude, 1 degree of longitude. Fascinating to be able to do this inside the 3D Scene Viewer as I'm doing right now. And on a other topic, and in my other videos, I do have an exploration of landforms, climate, land use, population density, and other things inside this same platform. Now we're focusing on the graticule right here, but just in alone here, you can see that you've got a lot of capability at your fingertips. So let's say right now you're teaching online, or maybe this is your normal teaching mode, and you don't have a physical globe to point to. There's nothing wrong with a physical globe, but I think this tool right here, these 3D scene capabilities, is even more powerful than you could do with a standard sized globe. No matter how big that globe is, you can't do what you're doing here. easily. Still valuable to have that globe. For example, teaching about the Great Circle Route and stretching a string across it. You can still do that, of course, and nothing wrong with that. But again, using this, and now I'm just looking at major parallels and meridians. I'm zooming in on the international dateline because what I want to do, and what I frequently do in my own courses, you probably do as well, but teach the difference between the international dateline, which is a artificially jogging sort of construct so that countries can be inside one day or another. It'd be way too confusing to have Tokelau and the Aleutian Islands be in 2 different days. So point out the differences between 180 degrees west or east longitude and the international dateline. As you can see here, there's some slight variation, as it is meant to be. So you can also discuss the International Meridian Conference of 1884, which I also explain in one of my books called Interpreting Our World. That whole event, 1884. Would have been fascinating to be at that. Now, another thing you could do is you can teach about seasonality and daily changes with the sun and the sun angle for different times of day, different times of year with this daylight tool, which is also standard in the 3D scene viewer in ArcGIS Online. So now I'm changing the month so I can talk to students about, gosh, why is it so shadowy in the winter, the December time period in the northern hemisphere, and why is it so sunny in the southern hemisphere at that time of year? So talking about summer solstice, winter solstice, the equinoxes, the vernal and the autumnal equinox with this same tool. Fascinating. Now, what time does the sun set in your community based on this tool here? What time is it going to set a month from now, 3 months from now, 6 months from now? Again, easy to do and very powerful. Inviting interaction with the students. You can have this on a projector or on a Zoom session or a Skype or something like that and demonstrate all this and ask questions of the students and do slices across the earth as I'm doing here right now. Or you can have the students using their own tablets, their own laptops, even a phone, but as I mentioned earlier, you're really limited on the amount of real estate on a phone. So I would highly recommend a tablet or a laptop for these activities. But again, at your fingertips with ArcGIS.com's 3D Scene Viewer. I think it's also instructive to change units and talk about units and why they matter, and pay attention to the units that you're using, vertical or horizontal. And these measure tools are at the fingertips there on the right side. And here I'm demonstrating that if you measure a long distance, you get the Great Circle Route displayed easily viewable. Why is that line curved? Talk to students about, hey, have you ever flown from Minneapolis to Frankfurt? Why are you flying over the southern tip of Greenland and even over the southern tip of Iceland? You're over the Great Circle Route. So you're not flying along a specific latitude. That would be longer than the Great Circle Route because we're living on a sphere, or more accurately, a oblate spheroid. Here I'm changing the base map to imagery, and I'm going to zoom in because this same tool, I want to illustrate, this same tool can be used, the 3D scene viewer, to investigate land use, land cover, and also terrain. So if you're teaching geomorphology, for example, here we are zoomed in on Colorado-Utah borderlands in the United States. Fascinating terrain in there, and we're going to take a look at one particular mesa, and we're going to use the zoom tools here, and we're also going to use the measure tool. You can also see the land cover here, very semi-arid environment, and you can see here that you can even teach about contours as I'm doing here, panning across and teaching about lines of equal elevation in this case. Now we're measuring across here, and we're seeing not only the vertical change but the horizontal change, and look at this. Again, great tool for teaching about geographic data and the Earth's shape, and how we measure locations on the Earth, specifically with latitude and longitude. And here we're looking at, you can see the different components of a distance, a over the ground component, and a vertical component. You can make the ground transparent. Depending on the layers that you have, might be a useful tool. I'm changing it to the streets view right now. Streets base map. You've got a lot of base maps at your fingertips, at least 25. You can also customize your own base map with your own fonts, your own colors, and there are plenty of tutorials to guide you into how to do that. We're going to pan over to another part of the landscape here. I'm going to illustrate a couple things toward the end of this video. This is a striking set of shale and sandstone cliffs called the Book Cliffs, and Mount Garfield in the lower left there. And I'm going to change it to, I've got terrain with labels now. Look at that. That is just amazing. You could teach about all sorts of things, landslides, slope, aspect. In the USA, you also have, as one of the base map layers, the USGS, or the U.S. Geological Survey topographic maps as a base map. So for those of you that love look at the orchard lands and the flatlands, and you've got the cliffs and the contour lines on those cliffs. So you're teaching about the basics of reading a contour map with what's an iso line, what's a contour line. This is a great tool for doing that. And you can also switch, of course, to the imagery and looking at comparing the imagery and what it looks like sort of on the ground or via satellite to the USGS topographic maps. Again, great tool for teaching, research, instruction, and much more. It is the 3D Scene Viewer in ArcGIS.com from Esri. Thanks for watching and keep exploring.